My name is Luis Montoya and I'm introducing Hadoop real-time SQL queries using Cloudera Impala. The design and implementation of Impala is based on Google's Remarks paper that was proposed as a complement to MapReduce for large-scale data processing. Impala is seen as SQL in HDFS. It provides faster response as it uses massive parallel processing, which means that it uses many CPUs running in parallel to execute a single program or a single query. Each CPU has its own dedicated memory. Impala does not involve the overheads that MapReduce has. It queries data stored in Hadoop and HBase, and so Impala is considered SQL in HDFS, while Hive is MapReduce in Hadoop. However, Impala implements HiveQL query types and can handle the same type of queries that Hive handles. That being said, Impala does not replace Hive, but it complements it. Hive is still the tool to use for big data batch processing. Impala is used for ad hoc or on-the-fly queries over a subset of some data. And Impala is not good for tasks that require heavy data operation due to the fact that everything being analyzed by Impala has to fit in memory. Impala is composed largely of the Impala daemon, which is installed on every data node of the cluster and functions as distributed query engine. The Impala state store that keeps track of the location and status of the daemons and maintains metadata for the Impalas executed on each node, and finally the command line interface. The advantage of Impala is that the data is processed locally. Impala processes only the data block within the node it belongs to and reads data locally, thus minimizing network load. On these diagrams, we can see an overview of Impala's architecture. On the right hand, we see that Impala and Hive work hand in hand, Hive doing the batch processing while Impala doing the interactive SQL queries. On the left side, we'll see the components of the Impala, and we have first of all the clients, which includes the Hue, ODVC clients and JDVC clients and the Impala shell. These clients are the ones that interact with the user for making queries. And then we have the Hive Meta Store, which stores the information of the data available to Impala. And finally, at the bottom, we have the Cloudera Impala. This process or daemons, they run on the data nodes. Each data node has one of those. And at the very bottom, we have the storage, which could be an HBase or HDFS. Cloudera Impala query language is SQL. Therefore, it implements the syntax like select, order by, group by, create table, insert statements. But because Impala is focused on analytic workloads, it doesn't have OLTP style operations such as delete, update, or commit rollback. How do we input data into Impala? Well, Impala is typically near the end of the extract transform load pipeline, so the focus is on working with the existing data rather than creating data from scratch. However, you can get data into Impala using these techniques like load data, like create external table with a location clause to point the Impala table at data files stored in HDFS. We also have the insert select statement to copy data from one table to another one. And but the preferred method of creating data for Impala is use any of the Hive data loading techniques that we'll see later. Because Impala and Hive tables are interchangeable, once data is loaded through Hive, you can query it through Impala. The execution, the query execution procedure, I can leave it as a reading exercise. I'm not going to discuss that. Now, going into the installation of Impala, there's two ways of installing Impala. One of them is manually, and I'm listing here the steps that are required to install in Impala. First of all, we need to install the CDH or the Cloudera distribution, including Apache Hadoop and some other tools that needs to be installed manually before you can use Impala. I didn't go through this process because it's long and it's tedious and it's prone to errors. There's an automatic method for doing that, and that's what I will be discussing next. Before going into the details, we need to point out that Cloudera Impala requires a 64-bit OS, and they suggest to use Red Hat or CentOS. I did do some experiments using Ubuntu 12.04 with good results, but in my experiments I use CentOS. So you need a Cloudera CDH 4.1 or higher, actually 4.5 or higher. Now Cloudera has CDH 5.0 in beta testing. You also need Hive and MySQL installed. And if you're using AWS or Amazon Web Services, you cannot use the T1 micro instances because the memory is not suitable for CDH. The recommended method of installation is by using Cloudera Manager, which is what I use in this project. When this installation is performed, you have done the following. You install a database application on the Cloudera Manager server host machine or on a host machine that Cloudera Manager can access, which will be this, where the user is located. You have installed the Cloudera Manager server on one of the cluster host machines. This will be this one here. And then you have installed CDH and the Cloudera Manager agents on all the other cluster host machines, like here. Alright, once you get into installing Cloudera Manager, you need to launch an AWS EC2 instance. I selected a CentOS 6.2. You can select also 12.04. And you have to select an M1 large instance and 20 gigabytes of storage. Also, you have to create a new security group with these settings. The TCP for SSH, port 22, you need port 7180 for the Cloudera Manager Web Console and all these others. One hiccup that I found was that the ICMP, the ping echo setting, I could not set it out to -1, so I put all values on it and the thing worked. And continuing with the installation, you have to select an existing key pair or create a new one. Once the instance is launched and running, you SSH into it, and then you have to get the Cloudera Manager installer bin from this website. You can hardly see it here, but that's because it's linked. It has a hyperlink. You change the mode and then you install it. When the last command is run, Cloudera Manager installation screen appears. You follow the directions in the manager to deploy the Cloudera cluster. This is the last screen of the installation on the when you SSH into it, which give you the instructions of where to point your browser, what is the user and password for the Cloudera Manager, and once you log in into the Cloudera Manager, this is the screen you get. Since Cloudera, Impala, and Cloudera Manager are open source, you don't have to pay for it if you use the Cloudera standard, and that's what I selected. Once you click on continue, you come to a screen that will allow you to select either a CentOS 6.3 or Ubuntu. I selected 6.3 CentOS. For the cluster instances, M1 medium type of instance, and I selected 3 instances. You enter your own access key and the secret access key, or you have to generate ones if you don't have them. And then you let Cloudera generate the key pair for these instances. Cloudera takes care of installing, actually launching all the instances for the cluster. All you have to do is just make sure that you download the key pair that Cloudera Manager generates for you at the end. Once you have that, you can go into the Cloudera Manager tabs, and there's all sorts of information that you can gather from it, like a status of all the roles that have the Cloudera Manager installed, and also you can see the hosts that comprises the cluster. At the bottom here, you can see that there are 3 hosts. One of them has 23 roles, the other 2 have 5 roles each. So you select the one with the 23 roles, and that's the one that you're going to be SSHing into to make all the queries and all the controls from it. Once you change the mode of the protections of the RSA key that you downloaded using Cloudera Manager, you can SSH into the instance with the Morse roles, and the first thing you do is you just change the ownership of the user directory and the root directory, and then instead of putting the files, which files? Well, I have to go back and tell that at this point I decided to reproduce homework 11 exercises as my proof that Cloudera's Impala performance is much better than Hive for this type of queries. So I'm using the All Bible file and the All Shakespeare files, but instead of entering and putting the directories as we're instructed in Homework 11, in here you have to make the directories input and Bible and put the files individually into them instead of putting the directories, because it doesn't work that way. I could make it work. And these screens will show you the all the instructions that we did. I did created the directories, I put the files in them, and then I created the tables that are required, like in Homework 11. And finally I started testing Hive to make sure that the Hive installation that we did with Cloudera's Manager is working, and it does. This last screen here is showing you that Hive generates the data that you request. Okay, once I'd verified that all the exercises of Homework 11 worked on with Hive on this installation, on this cluster installation, I was ready to try it out Cloudera Impala. In order to get into the Cloudera Impala, you have to issue the command Impala shell, as spelled here, and you need to make Impala aware of the existence of the tables, because when you initially try to show the tables using Impala, they don't show. So how do you do that? You invalidate the metadata using the statement invalidate metadata, like I said here. This causes Impala to reload the entire metadata catalog, and then you have to refresh all the tables using the command refresh and the table name, like I did here in the screen. You'll see that I'm refreshing all the tables, and then once I did the show table again, I can see the tables already in the Impala shell. Well, as I said during the introduction, all the commands and queries that you can do in Hive, you can do them here in Impala. That's not exactly true. Impala uses SQL commands, and the command sort by is not a SQL command, but it's a Hive command. So I had to modify some of the lines here and replace the sort by with the order by on this, and I created a SQL file that I'm going to be running using Hive, and I'm going to be running using it in the Impala, and compare the results. you can see that on this screen, this file contains all the experiments that we did with Hive, and we're going to be running next these tests both using Hive and using Impala. And these are the results. On the left side on this screen, you see the results of running that SQL file or SQL file on Impala, and you can see that the response time, I timed this command, and the response time is less than 7 seconds, while running the same command on Hive, it takes 7 minutes, over 7 minutes. So you can see that the results are very dramatic. The improvement on using Impala versus Hive is 60 times better or more. Next, I'm going to continue by doing some live demonstrations, and here's the screen to do the demos.